A beetle survives in the desert by harvesting water from fog that collects on its back. Lotus leaves stay healthy because of complex cleansing abilities. Scientists at Sandia Labs have studied and built on these amazing examples of how nature solves difficult engineering problems. Incorporating nano to microscale roughness, they've formulated a transparent solution that makes any surface super water repellent or super hydrophobic, and the effects are immediate.
There are many ways now to make super hydrophobic surfaces, but most of them include either specialized processing steps, vacuum treatments or high temperature, or they're substrate specific. You can only put them on one type of substrate, or they involve many complex steps. So you apply it, then you have to do many manipulations to develop the super hydrophobicity. So what's unique about our material is that we can apply it to any surface by simple spraying, dipping, spin coating, any common deposition approach. And the super hydrophobic property develops immediately, and this is because our material is quite unique in that as it dries, it actually expands upon drying, creating the necessary nanoscale porosity which is requisite for the super hydrophobic behaviors. It's exciting for us because I think if you look at these super hydrophobic surfaces, you see that they have fascinating properties. Water bounces and rolls on the surface. You can clean material from the surface. We can pattern the direction of flow of the droplets on the surface. And I think, these are all very exciting aspects of these materials.
Exposing a coated surface to a particular frequency of light through a photomask creates patterns of water-hating and water-loving regions. This can mimic the desert beetle's back. The list of real-world possibilities for this film continues to grow.
We have interactions with industry where they want to use these types of coatings to avoid corrosion of aircraft. So there's a big issue, of course, with any kind of aircraft where you would like to avoid metallic corrosion. You also want to avoid icing on wings, and so these super hydrophobic surfaces might be useful in those regards. Also, if you apply this material to a surface, it keeps the surface dry, and if you keep a surface dry, it won't corrode, and so this is a very simple way to develop that property.
Additional potential applications for this coating process include finding new ways to collect water that could improve the quality of life in extremely dry regions, the collection and analysis of particle contaminants like anthrax, and as an additive to paint and other coatings to prevent mold and mildew. Scientists are also excited about attractions between hydrophobic surfaces underwater that may help guide the complex folding of proteins from their initial passive shape into the active formations upon which life depends.